Hey guys, welcome. We're going to do the rest of the multiple choice. This is questions 5 through questions 9. So let's do it. It says, in these next two questions, a researcher wishes to compare the average amount of time spent on extracurricular activities in high school in a suburban city with that of a school in a large city. The researchers obtained 60 high school students, 60, in the suburbs. So this is the suburbs. All right, and they found that the mean time spent doing extracurricular activities was 6 hours. All right, plus or minus 3 hours. So that means somebody spent up to 9 hours, somebody spent 3 hours, but on average they spent 6 hours. All right, now the research also obtained independent, we like that, of 40 high schools in larger cities. So in a larger city, what was the average? And it was 5 hours a week, plus or minus 2 hours. So this looks different. But again, we know how variability works. Any two things are going to be different. Is it different enough to be significant? So as we keep reading it here, it says, suppose that the researchers decided to carry out a significance test of H sub O. And so that would be H sub O, or you could say mu S minus mu C equals 0. What would be H sub A? So when they say this, they mean that part is the H sub A. What's that mean? That means that they're doing a two-sided test. So what they mean by that is that they don't know whether, they don't have a sneaky suspicion whether the suburbs, because they haven't taken this data yet, they don't know whether it's more in the suburbs or more in the city. They just want to know if the two are different, okay? So what that means is if the suburbs were more, you'd get a p-value at least as extreme, or if the city were more, you'd get a p-value at least as extreme. So this is why it's called a two-sided alternative, and that's the letter A for alternative. So what is H sub A? H sub A should be mu S is not equal to mu C. Okay, is this a Z or a T test? So did I ask yes or no? Absolutely not. I measured something. So normally if you measure something, it's going to be a T test unless they give you sigma. I see no sigma, so this is going to have to be a T. Why? We measured something and we are not given sigma. All right. Now, we would have had to have been given sigma for group 1 and group 2 or told the sigma for both groups is the same, but whatever. Okay, so what's our formula? So let's tap into our formula sheet here. It's proven to be pretty handy. So we're doing this type of test, and we're going to do a confidence interval. Does that make sense? Or wait, what am I doing? They said to do a stat test. Okay, so getting ahead of myself, that's what I'm doing. So this is not a mean difference. The people are totally separate groups. So it's definitely I measured something and I'm going to do a stat test. So what's the formula? That's my formula. So let's write that out. Copying it over from our formula sheet just to kind of practice and get used to it. All right, sorry about that. It's kind of off the screen there. So I copied this formula there. Now, how's this going to help me? It's going to help me because I can see if they plug this information in correctly or correctly. So x sub 1 is 6, x sub 2 is 5, and what is my mu naught? It's 0. Now, what should be in the denominator? My standard deviation of group 1 squared over N1 plus my standard deviation squared over my N2. So looking to see which one matches, it looks like that's a perfect fit for E. Cool, right? Okay. Going to 10.6, the p-value for the test is this, right? And the correct conclusion would be what? So it's not required for this question, but I'd love for you to confirm the p-value here because we have all the ingredients, and the more we practice this, the better we'll get. Okay, So let's answer the question first though. Since all of these say at this level, so the p-value is 0.048, and since that's less than alpha, 0.05, we should go through door number 1, reject the null hypothesis. All right, so these are out. Now, what else does the poster say? The poster says there is convincing evidence that there is a difference. So we're going to pick E. Now, what if the same test question would have been free response instead of multiple choice? So I'd like you to fish your way through that again and get even more. I think this is the 3rd time we've done this. We're going to do a stat test, right? And this is a 2-sample T. Why? I have summary statistics about 2 groups. X sub 1, I got all that. 6 hours, 3 hours, 60 in group 1. 5 hours, 2 hours, 40 in group 2. And they told me to do a 2-sided test, so I did. And there we go. So look, a p-value. So that's exactly the p-value they got, and so did we. So I'm going to write down the degree of freedom here because, again, it's just good practice. And what's the name of the test? This is a 2-sample t-test for mu1 minus mu2. Okay, so what was the t or the z? This was a t-test because we didn't have sigma, and my t was 2. So I was 2 standard deviations from the mean to the left and to the right. So this was 2 and -2. So they gave me the area under the curve, both to the left and to the right. Okay. Awesome sauce. So, question number 7. At a baseball game, 42 out of 65 owned an iPod. 42 out of 65. And at a rock concert, it says 34 out of 52. So this is the rock concert, and this is baseball. So they're trying to figure out, these are totally separate groups. So this is the same type of test. This is a 2-sample, right? It's not a mean difference, but we asked them a yes or no question. So this is going to be a 2-sample Z interval, right? Because we have a confidence interval. And what's my level? It says they're going to do it at a 90% level. Okay, so a 2-sample Z interval for P1 minus P2. What's the difference between the two population proportions? So they came up with this. It's not required for the question, but I'd like you to put it in the calculator because it's great practice. So I'm going to go stat, confidence interval, and I'm doing a 2 proportion Z because I have 2 proportions. The proportion of people at the baseball game and the one at the rock concert. So 42 out of 65 said yes, I got an iPod. 34 out of 52 said yes, I have an iPod. And at the rock concert, and I have a 90% level. Okay, so let's take a look. Interesting. I dorked up, guys. How did you let that happen? I got to do a confidence interval, 2 proportion Z interval, 42, 65, 34, 52, 0.90, enter. Okay, there we go. So here's my data. My P difference, there was a slight difference, 7692. Margin of error, 0.1459. P1 hat was 64% at the baseball game, or round up to 65. And oopsies, guys, if I round 65% at the rock concert and 65% at the baseball game. So what question am I truly asking here? I'm asking if there's a difference. That's really what the question is. And it looks like judging from my interval, since 0 falls in there, ooh, because the confidence interval includes 0, right? Then the researchers cannot conclude that there is a difference. The researchers cannot conclude there is a difference because we actually have evidence that sometimes it was bigger at the baseball game, sometimes it was bigger at the rock game. So that's, no, got to pick that. All right. Next question. An SRS of 100 is taken from pop A and it has a proportion of that. An SRS size that is taken from population B. The sampling distribution for the difference between the two populations, what would be the mean and standard deviation? Okay, so we did this in class, and the mean of the difference of proportions should just simply be equal to the difference you got. And so what difference would you get? Well, the difference between 0.08 and 0.05 is 0.3. So first, notice they all got to the same answer. So we know that's the right answer. So what's the standard deviation? Well, let's take a look at our formula again. So this is a proportion question, right? And our formula would be, this is the standard deviation inside of here. That's where we're getting this from, right there. So our formula is P1 hat, 1 minus P1 hat, over N1 plus P2 hat, 1 minus P2 hat over N2. Take the square root of the whole thing. That's my standard deviation of that distribution. Now let's plug this stuff in. The first one's supposed to be 0.8, and 1 minus that would be 0.2 all over the sample size of 100. 0.05, 1 minus 0.05 is still 0.5 all over 400. Take the square root of the whole thing. So how do we type this in? This calculator is so fancy, I can literally make it look just like that. So the square root of parentheses, 0.8 times 0.2, divide by 100, plus 0.5 times 0.5, divide by 400, parentheses, enter. Look at that, looks just like that, right? And I get 0.04717. 0.04717, so I pick C, 0.047. Yep. Last question. How much more effective is exercise and drug treatment than drug treatment alone? To find out, researchers performed a completely randomized experiment involving 1,000 healthy males. Half the subjects are assigned to receive the treatment, so half. So we didn't do the treatment like in class where you got strategy A and B and both were performed on the same person. So are the same subjects used in both groups? No, it's not like our activity with memorizing words. So we know that it's not mean difference. So now we have to decide, is this a proportion question? Am I asking a yes or no question, or am I measuring something? So let's keep reading. Each were assigned a treatment and the other half exercising and receiving treatment. The most appropriate inference method would be what? So we have to answer the question, what question were the subjects asked, or were they taken a measurement? So let's read again. It says, how much more effective is exercise and drug treatment than drug treatment alone in reducing the rate of heart attacks? So what did we ask them? We asked them, did you have a heart attack? And they had to answer that question, yes or no. So after we studied them and we let a certain amount of time go by, we're literally just keeping track. Did the person have a heart attack or did they not? And that would help us decide if that treatment did or did not reduce the rate of heart attacks. So what do I need? I need these guys, right? And not that, not that. Or this word proportion. But I had two separate groups, so it's not a one sample. And we simply have to decide which inference method now that we want. Did they ask us to do a stat test or an interval? So we see here that the most appropriate inference method would be B, to do an interval, because that would provide more information than just saying you do or do not have that information. Thanks for joining us, guys.